questions? Well, if I want to make it more interactive, I want the sprite to give me a speech bubble and tell me that the square of a particular number is blah blah blah. Okay, so there are several ways to do it. I'll do it the clumsy way first, and then we'll do it the more cleaner way. To do it more clumsily, I need to use another variable. Okay, I'll make another variable here. We'll call this one y. Okay, and in the program here, what I'll do is I will set x to the original number, say 15, but I will set y, my other variable, to the square of the first number. So that this way I can display both the first number as well as the second number. Is that making any sense so far? Okay. And I will also make this really clumsy and not very intuitive at first, because what I'll do is I will use the speech bubble, and I will spell out what the first number is, and then I'll spell out the second number. Okay. And I can change the number of seconds to display the speech bubble from 2 to, let's say, 4 seconds. That gives us a little bit more time to explain what is going on. The way it is right now, it will only say hello. Okay. In other words, when we get to this purple step here, it will just have a speech bubble with hello exclamation point in it. Wait for 4 seconds, and then it will display the second speech bubble, which has exactly the same content, also for 4 seconds. That's not what we want to do. We want to show the original number, which is x, and then we want to show the square of the number, which is y. It's not a big deal. We can do this. We can go to variables and say, don't say hello. Tell me what x is in the speech bubble. Don't say hello. Tell me what y is in a speech bubble. Okay, so we'll go ahead and run this program just the way it is right now, and let me save it as a different name. I guess that's okay so far. And I run the program. Ask me for a number. I input, let's say, 12 this time, and it will display 12. Wait 4 seconds, and it will display 144 for 4 seconds, and then the program is done. Okay, so I'm incrementally making the program more interactive, and also having the answer spelled out in a more reasonable way, so I don't have to show the variables anymore. In other words, what I can do now is I can stop the showing of the variables on the top here, so the program looks cleaner. Are we doing okay so far with these concepts? Yep, go ahead.
Could you mix text with the variable there too? Like the variable x is, and then you can make it put like x in there?
Yes, that's the next step. Because the way it is right now is really cryptic, right? It just shows you a number, wait 4 seconds, show you another number, wait for 4 seconds. So it doesn't tell you the square of this number, 12, is 144. That's what we wanted to do. But as it turns out, that is not a very simple thing to do. Okay? Because in order to do that, we have to somehow mix, some words that we can type verbatim with the value of the variables, right? Because what we want to do is to say the square of, verbatim, okay, exactly the way as we type it, but then the square of the next thing will be substituted by the actual value of x, instead of the x as the letter x. And then is verbatim, and then y will be the value of y and not the letter y. Okay? So we'll just go ahead and do something that is not so reasonable first, and then we'll fix it so it's more reasonable. We'll insert a third speech bubble. And this time I'll just tell you what the problem is. I can show you what the problem is, and then we'll fix it. And we'll change the program because we are making changes to the program. So with each important step, I'll save it as a different version. So that way, when you guys are home, you can load the different versions and see how the program gets changed incrementally. Or you can watch the video clip again, and that will also show you all the steps that I take to change the program. So I'll just call this more interactive square. And you can see how this naming convention is not going to be very good, because it would just be most interactive square, ultra interactive square, super duper interactive square, and so on and so forth. Okay, so what we'll do is we'll change this speech bubble to say the square of x is y. Now, we kind of know this is not going to work, but I'm just hoping that for some reason it will recognize x means the value of x, not the letter x, and y means the value of y and not the letter y. So we'll go ahead and see whether it does it or not. And since we're going to change it this way, we'll take away the other two speech bubbles, because we are changing the program. And to remove something, you just take it out of the sequence and drag it to the left-hand side, and it disappears. So let's go ahead and run the program, and let me give it, let's say, 9 this time. It should display 81. And all it does is to say the square of x is y, without actually showing me what x is or what y is. So now what I need is the ability to kind of mix things up a little bit. Okay, a part of the speech bubble is something that I want to type verbatim, and a part of it has to do with the value of variables. To do that, you need to go back to operators and basically look into the join operation. The join operation, as the name implies, joins two words into one construct, one sentence. In this case, if you look at the default values, it has hello with a space on the left-hand side and world on the right-hand side. The join operator is concatenation. That's all it does, is concatenation. All it does is to say, let me make one thing out of these two things. So as a result, join hello world is basically hello space world. That's the result of the join operation, which is also called concatenation in programming. Well, I'm not so convinced, so let me just go ahead and click this, and it shows me the result is just hello world. Is that okay so far? Well, that seems somewhat useful. Okay, let me just kind of drag this over and play with it a little bit. Okay, I'm going to drag this into the content that I want to print out using the speech bubble. And I just want to do one thing at a time. I just want to say the result is something, okay? So what I can do is to say the first part is not hello anymore. Instead, it is the result is with a space, okay? Don't forget the space. The second part is the value of the result, which is y. So I would go to variables again, and this time I drag y over to become the other part, which means if my understanding is correct, this join operation will basically join the literal part, which is the result is with a space, with the actual value of y at the time that this statement executes. So it should display the result is, and then followed by the square of a number, right? And this is what you should do when you write a program. It's not just play with it, but you should anticipate what a statement should do, and then run the program and see if it is executing the program the way you expect it. In other words, programming constructs are not a box of chocolate. You have control over what you want to do, and you should know what the result of the execution of that statement. So I would input a number, let's say 7. Okay, what should be the output this time? What should the speech bubble say this time? It should say the result is space 49. Okay, it should spell out 49 and not just say y, right? So we'll go ahead and see whether it does exactly that. And sure enough, it tells me the result is 49. Okay, so it looks like it is working. Okay, this join operation or join operator is the key to customize the message so that parts of it can be based on a variable and parts of it can be based on something that I type literally. Are we doing okay so far with this concept? But it's still not doing everything that I wanted to do, because I wanted to spell it out to say the square of a variable is another variable. That's what I wanted to do. So let's see how we can do that. Okay. So what we want to do is we need another join operation. I think we need we need two more join operations. Now this is the interesting part of programming. It's not just with Scratch. With any types of programming, in fact, in any type of math, you have to pay attention to nested operation. What is a nested operation? Let's just, let me just use Notepad here to show you what a nested operation looks like, because we all know what a nested operation is. It's just that we never call that a nested operation usually. So I would use just any type of editor would do. Accessories, gedit, that's fine, okay? So if I tell you that we have to do some computations, okay, let's just say that we are shopping at Macy's. Okay, the reason why I use that as a topic is because I hear about that all the time from a certain who. Okay, so let's say one item is $25. The second item is say $20. The third item is $15. And on that particular day, everything has a 10% off. Now, if you take 10% off something, that means you're multiplying that thing by 0.9, okay, because you take 10% off. But out of the whole thing, because I'm using a gift card, that means the amount I have to pay is deducted by a certain amount. Let's say I'm deducting the whole thing by a certain gift card by, let's say, $10. Macy's, send me a little gift card and say, hey, come on in, and we'll give you $10 back if you buy more than a certain amount. And this whole thing, because I'm using a Macy's credit card, it will give me another 15% off out of the entire thing. So that means I have to multiply another, well, let's make it even more interesting. 1 minus 0.15 is the amount. Okay, let's just say that I don't know how to calculate what is taking 15% off. Well, I leave it to the computer to do all the calculations. But don't forget Uncle Sam, because Uncle Sam wants his own share, which means the amount of money I have to pay over the counter is 1 plus the tax rate, which is 875 in Sacramento? Or is it 825?
I think it's 875.
Yeah, I think that's the amount. So this entire thing tells me how much money I have to pay out the door for this particular purchase. Is that making any sense? But how do you calculate it? Well, you start with the stuff that is embedded the deepest inside the nesting of the parentheses. So the first thing you would do, okay, if I want to show this step by step, is to compute the addition. There are several things I can do first. I can do several things all at the same time. I can change this into a single sum of these three numbers, and that's going to be what? 60. Is it 60? Yep, it is. Okay. So I'll just replace this whole thing by 60 because I have to resolve everything in the innermost part first, and then we get out, step by step.
That's called PEMDAS.
PEMDAS.
The order of.
Oh. Well, this is actually an inconvenience because we use infix notation. I can show you a very confusing example of what we call a postfix notation, where there's no such thing as parentheses. There's no need for parentheses. I'll show you the equivalent form later on. Now I can do this calculation here. Okay, this one is 0.85, and then this one here is just 1.0875.